Has Jordan ever been hit by a hurricane before this?
Okay, today we're going to be discussing converting radicals and roots or roots to rational exponents and vice versa. So we're going to be going back and forth. This is a new topic for us when it comes to having a rational exponent. We're going to get more into what rational exponents are in just a minute. But let's first talk about radicals. This is something you should know. A radical is an expression involving a root. All right? The symbol that we use is called a radical symbol. The number or variable or whatever it is, expression, underneath the square root, the radical symbol, not square root symbol, the radical symbol, is called the radicand. The type of root that we are taking is determined by the index. The index indicates what root we are taking. For square root, we don't put a number there. It's understood to be a 2. For every number greater than 2, though, you have a 3, 4, 5, 6, whatever. It could be 19, could be 1,000th root, whatever. We usually put an N to represent the index. All right, questions about that?
Hello, Coach. We got a can. All right, I got this.
Okay.
Red in the can. Man. I'm talking about.
What did you say? What he was like?
Okay, so rational numbers is any number that can be written as a fraction where the numerator and denominator are integers, such as 1/4, -3/5. You could go on and on and on. Okay, as long as those numerator and denominator components are integers, that's a rational number. All right. So in layman's terms or in common mathematical terminology, we just say it's a number that can be written as a fraction. All right. Rational exponents. These are exponents that are fractions with integer parts. Okay, let's go on to the next slide. Let's take a look at some examples. So y'all just write these examples as we go. All right. Start over on some of this.
Are you still recording?
Okay, so let's take a look at some examples. The first example here is 4 to the 1/2. Notice the exponent is a fraction. A rational number is a fraction, right? Number that can be written as a fraction. So we've written our exponent with a fraction. Now what does this mean? A number with a rational exponent, a fractional exponent, is really just a radical, a root of some sort. And the parts of the fraction tell us what type of root it is and how we should convert it. The numerator of the fraction is the exponent of the radicand. In this case, the base of our exponential expression, the base is the radicand. That's the number that goes underneath the radical symbol. The denominator is the root that we're dealing with. The root is like square root, cube root, fourth root, and so on. All right? So we can convert this to radical form very easily. The 2 is where we start. 2 means square root. So that tells me I'm going to have the square root. Now, do I need to put the 2 as the index for square root? No, we don't. If you did, I wouldn't count it wrong. But it's unnecessary. It's like putting a 1 in front of an X. There's an understood 1 there, but you don't need to write it. So this index of 2 is understood. That leaves 4 to the first. Do I need to put the 1 there? No. The square root of 4 is what? 2. 2. So that's how that simplifies. All right, let's go to the next one. Okay, so I'm always going to work my way from bottom to top. I'm going to start with the cube, the 3. The 3 means cube root. So, cube root of what?
X to the second.
X to the second. Okay, can you simplify that? Nope.
That's nice.
What's the next one? Cube root.
64 to the first.
64 to the first. Now, can you cube root the 60? Can you take the cube root of 64?
It's 4.
Yes, it is 4. So that one can be simplified. All right, let's do some more. Let me erase what I had previously
Pretty hard,
written.
man.
That's all you. That's all.
Oh man, this stuff's super
This
easy.
is a bad man with them here, baby.
All right. Okay, let's look at the number 4. All right, and number 4, 8 to the 2/3.
Cube root of x to the second.
Okay, cube root of 8 squared. Now, what is 8 squared?
64.
64, so it's the same problem we just had, right?
Yes, sir.
So it's 4. All right, what's next?
Fourth root.
4th root
60 to the third.
of 16 cubed. Now, we can simplify this. 16 cubed is, let's see if we can simplify it. We may not be able to. Okay, so this is going to be the cube, the 4th root of whatever 16 cubed is. It happens to be 4096, 4096, and it comes out to be 8.
Sheesh.
Okay, now you won't always be able to simplify these roots. In this case, we could. All right, look at the next one. There are 2 parts to this product. You've got x to the 1/2, you got y to the 3/4. Let's take it one piece at a time. So how would you write x to the 1/2? Square root of x times. All right, how would we write y to the 3/4? The 4th root of y cubed. Now, can we combine those? No, you cannot combine them. All right, so you just leave it, just like this. That's as simple as we can make it. All right. Now we'll get into going backwards. Let me erase some stuff real quick. Okay. All right. So let's go backwards. Okay. Now, if I'm going backwards from, I say backwards, it could be forward. I don't care how you think of it. But we're going from a radical to a rational exponent. What, first of all, is going to be the base of my exponent?
5. 1 over 4.
Not yet.
5 is going to be, I said base, I didn't mean base.
X 1/5.
What is going to be the denominator of our rational exponent?
It will be 5.
It will be 5. So let's go ahead and write this stuff in parentheses, because that's all one thing right now. And I know it's going to be to the 1/5, right?
Yes.
Now, I can adjust this a little bit, because what are the rules of exponents? The rules of exponents say that when I have an exponent outside parentheses, I need to multiply by every exponent inside parentheses. So I would take it either way. I would let you leave it like this, or you could do x to the 1/5,
That's how I would have done it.
y to the 3/5. Either way, I will take. All right, it'll be all right. Let's look at the next one, number 8. We got the 6th root of 17. So how am I going to write that?
17, 1 over 1.
Yep. 17 to the 1/6. All right, we got the cube root of 81. How am I going to write that?
81, 1/3.
81 1/3. Okay, so we've been able to see how we go back and forth. Now just be careful and make sure that whatever is underneath that radical, make sure you keep it together in parentheses until maybe you decide that you want to simplify like we did here. Keep it together, all right, so you don't get confused. Use the rules of exponents. The rules of exponents will take you to the answer if you are consistent. Now, we're going to practice this stuff. And we're going to do it kind of like a little game. So, we're going to stop our video and we're going to look at this.